In this video, we will be exploring how to model an exponential function using exponential regression and the Desmos calculator. The first thing we're going to do is type in our table of values right here in problem 9. The table below gives the number of Y values of cell phone subscribers in millions from 1988 to 1997, where T is the years since 1987. So the first thing you need to do is put in your data, add the plus sign, and then select table. In the table, I'm going to put T in X1, and the Y values are going to go in Y1. Okay, now as you can see, I've entered the values in the table. So the 1 means this is 1 year since 1987, and there were 1.6 million cell phone subscribers. Take a look at how the points on the graph paper are progressing, and you can see how this will model an exponential function very easily. Okay, so now we need to type in the function. We're going to go to line 2. We're going to add an expression in line 2, so we're going to say y1. So y1, and then we need to pick the squiggle, which is in the keyboard, is approximately equal to a times, going back to the alphabet, b, go back to the number pad, and I'm going to choose a to the b because that will allow me to type in my variable. And that's going to give me an equation that models the points on the graph. Let's take a minute and notice what we have here. So we have an approximation, that's why the squiggle is there. So we can say that this curve approximates the data in the table. Notice how it's not an exact fit. One thing I want to remind you of is your r squared value is going to tell you whether or not your curve is an exact fit. Our r squared value is very close to 1, although it's not equal to 1. So I can say that this is a very close fit, but it's not perfect. The other thing that it gives us is we have numerical values for A and numerical value for B. We're going to use this information to come up with a general formula in which we can use to make predictions and then determine the number of cell phones in the year 2001. So that's going to be our next step. Okay, so let's take and look at line 3, and we are going to type in y equals, go to your letters, and this is going to be A, back to the numbers, go back to the letters, back to the numbers, and back to the letters one more time. And put in your X. Okay, so there's my equation. Okay, so to take an equation and to turn it into a table, in line 3, click on the settings wheel and select table. And what this table will allow you to do now is it will allow you to make predictions. And I can type in values now. So if I want to know what happens in the 14th year, I can say that I'm at 186.73127. So here's my basic model that we found on the Desmos calculator. In order to figure out my answer, which is clearly not on the graph, because 14 is out here, so all I can do then is use my model to make a prediction. So I would do 1.39 raised to the 14th power. So y is approximately 192.98 million cell phone subscribers. Obtain the exponential function that models this data. Don't forget to explain what the variables used in the model mean. So here's what we did on the calculator earlier. And just in terms of explaining what the variables mean, 1.39 is the base. I know it's the base because it's being raised to the x power. So this indicates that it's exponential growth. 1.29 is the initial value. So this is going to be the approximation of the original amount of cell phone subscribers. Okay? So before I show you the graph I made, I want to take a minute and look at the axes, because when you sketch the graph, you have to also label the axes. I looked at my table of values and I noticed that t went from 1 to 10. So I labeled my x-axis
as t, and that's my independent variable, and I'm going from 0 to 10, where t represents the years since 1987. Okay? Then I labeled my y-axis. I chose to go from 0 to 50, counting by tens, because y represents the number of cell phone subscribers in millions, and I looked at my y values. They started at 1.6 and they went up to 48.7, so I thought 0 to 50 was a good scale. Then what I did was I plotted my points, and these points are from the table. So this is like 1, 1.6. This is 5, 8.9, which is in my table right here. This one is at 10, 48.7. Okay, so I'm going to sketch my graph. Now, if you notice, my graph on my Desmos calculator didn't exactly fit. Remember, our r-squared value was around 0.99 something. So it actually starts a little higher than the 1.6 in my table. It actually starts at 1.92, which is really a little difficult to indicate on here, but it doesn't exactly go through the points. So when you sketch it, it's okay that the curve is a little off because the r-squared value isn't exactly 1.